Precious friends, I really hope that you are doing great. Welcome to our today's class. It's our 6th lesson on vectors, whereby we are looking at a past Kcse question done in 2006. The same question was also repeated in 2016, paper 1 question number 20. So the question reads that in the diagram below, the coordinates of points A and B are 1, 6 and 15, 6 respectively. Then point N is on OB such that, so we are told that 3 or N is actually equal to 2 or B. So for me to interpret this particular ratio, I'm going to divide through by OB. I also divide through by OB so that OB will cancel out. So I remain with 3 or N to the ratio of OB being equal to 2. Then I divide through by 3. I also divide through by 3 so that the ratio of ON to or B will actually be equal to 2 over 3. So if I consider the line having ON and OB, of course it's this line ONB. So if I sketch this line here, we have O, then of course we have N in between, then we have B. It simply means that the ratio of ON will actually be 2. So this ratio is 2. Then OB, its ratio is 3. Remember, OB is the whole line. So if this is 3, then this ratio is 1. So that 2 plus 1, you'll get 3. So it means ON has a ratio of positive 2. Then NB has a ratio of 1. Then we also interpret the other given ratios. So we are further told that we are also told that line OA is produced to L such that OL is equals to 3 OA. OL is equals to 3 OA. So if I divide through by OA, I also divide through by OA. OA into OA one time, OA into OA one time. So this will be OL to the ratio of OA will actually be equal to 3 times 1, I'll get 3, then of course divided by 1. So if I consider the line having OLA, of course it's this line OAL. So if I look at this line, this is coordinate O, the A is in between, then this is L. It means the ratio of OA will be 1. So this ratio is 1. Then OL, that is OL, is 3. Remember, OL is the whole line. So it means this ratio is 2. So that 1 plus 2, you'll get a ratio of 3. Therefore, our OA has a ratio of 1, whereas AL has a ratio of 2. So that is how we interpret that. Then, after interpreting the ratios, I'm going to move to, that is part A of the question, whereby I'm told to find the vector Ln. So we can only find that vector if we have the coordinates for point L and also the coordinates for point N. Therefore, to find the coordinates for point L, I'm going to use the line OAL. Of course, I combine with what we call the ratio theorem, which is taught at Form 3 level. So we need this particular line. So we have the O here, which has the coordinates of 0, 0. Then the other one is point A is in between, which has the coordinates of 1, 6. Then of course, lastly we have point L, whose coordinates are not known. Now remember, when we talk of the ratio theorem, suppose you have a line here. Maybe this is point A, then this is point B, then of course this is point C. Then of course, if we let the ratio to be Mn, then the ratio theorem dictates that the coordinates for point B will be given by, you simply take M divided by the total ratio, which is M plus N. So this one will be, this one should be multiplied with the opposite coordinate of point C. Then I'm going to add N divided by the total ratio will be M plus N. Then this one should be multiplied with the opposite coordinate, which is actually the coordinate for point A. So applying the same here, we are going to have the following. We already have the ratios for OA, which had a ratio of 1. Then AL had a ratio of 2. So if I apply the ratio theorem here, it means that the middle coordinate, which is the point A, so the coordinates for point A, which is actually can be written as OA, should be given by the ratio, which is 1, divided by the total ratio, which is actually 3. Then this one should multiply with the opposite coordinate, which should be the coordinate for point L, which we can write as OL. Then of course we are going to add the other ratio is 2, then divided by the total ratio is 3. Then this one should multiply with the opposite coordinate, which are the coordinates for the point 0, 0 or the origin. So if I substitute my coordinates, OA of course simply means we are going to consider the coordinate for point A, which is actually 1, 6. So this one should be equal to a third. So this is a third of OL. OL, of course, we are going to use the coordinate for point L. Then we are going to add 2 over 3 into the coordinates of the origin, of course, which are 0, 0. But we know that when you multiply 0 with any number, the answer will be 0. Therefore, it means that 1, 6 should actually be equal to a third OL. So this is a third OL, then of course plus 0, or simply put 0, 0. So if you subtract 0, 0 from the other side, you'll just remain with 1, 6. So 1, 6 is equal to a third of OL. So this is a third OL. So if I want to get the coordinates for OL, I'll multiply through by 3. So I multiply this side by 3. I also multiply the other coordinates by 3, so that the 3 and 3 will cancel out, so that I remain with OL actually being equal to 3, then of course into 1, 6, 1, 6. So this one should be equal to, let me separate using my line here. So this one should give us the following. This should give us OL having the coordinates of course 3 times 1, I'm going to get 3, then 3 by 6, I'm going to get positive 18. Therefore, the coordinates for point L is actually 3, 18. So point L has the coordinates of 3, 18. Then I also apply the ratio theorem to find the coordinates for point N. So I'm going to use the line ONB. So I need line ONB. So this line here. So this is the O, which has the coordinates of 0, 0, of course. Then here we have N, whose coordinates are not known. Then we have B, which have coordinates of 15, 6. So this is 15, 6. The ratio we have already determined, which was 2, 1. So applying the ratio theorem, the coordinates for N, which can actually be indicated as ON. So this should be equal to, so I'll take 2 divided by, the total ratio is 2 plus 1, which is actually 3. Then I multiply with the opposite coordinate, which is actually vector OB. Then I need to add, the other one is the ratio is 1 divided by, total ratio is 2 plus 1, which is 3. Then we multiply with the opposite coordinate, which of course is the origin or the 0, 0. So it means that ON will be equal to 2 over 3 into OB. OB simply means the coordinate of point B, which is actually 15. So this is 15, 6. Then you are going to add a third into, so a third into the coordinate for the origin, of course, is 0, 0. So this should give us, so this one simply means that 2 over 3 I should multiply with 15. So 2 over 3 multiplied by 15. Then we are also going to have 2 over 3 multiplied by 6. Then you are going to add, of course, a third multiplied by 0. You are just going to get 0, 0. So this should give us, let me create some working space here. So we are going to get the following. So this will give us the following. So if you take, of course, 3 into 15, that is 5 times. So 3 here 1, 3 here 5 times. Then of course 3 here 1, 3 into 6, that is 2 times. So it means that our ON, so it means that ON will actually be equal to 2 by 5. I'm going to get 10. So this one will be 10. So 2 by 5, I'll get 10. Then 2 by 2. I'm going to get 4. So 4. Then of course, if you add to 0, 0, the coordinate will just remain to be the same. So it means that our ON, the vector ON, is actually equal to 10 plus 0, you'll just get 10. Then 4 plus 0, you'll also get positive 4. So it means that the coordinate for point N is actually 10, 4. So this is 10, 4. So these are the coordinates for point N. Now, having found the coordinates for both L and N, we can now find the vector for Ln. So the vector Ln simply means that you'll take the coordinate of point N, which is ON, then you subtract the coordinate of point L, which should be equal to, so our coordinate for point N, we have found it as 10, 4. So this is 10, 4. Then you are going to subtract the coordinate for point L, will actually be, point L is 3, 18. So this is 3, 18. So if I perform the subtraction, I'm going to have the following. So 10 minus 3, I'm going to get positive 7. Then of course 4 minus 18, I'm going to get negative 14. So this will be negative 14. So this is actually what we are calling our vector Ln. So this is our vector Ln. Then we move to part B of the question. So part B of the question, we are given that, let me create some working space here so that we can use it. So in part B of the question, we are told that we are given that, so this is part B of the question. We are given that the point M is on Ln such that we are given some certain ratio here, that Lm to the ratio of Mn is actually equal to 3 to 4. So that let's look at line Ln. This is our line Ln. We are told that M is on Ln. So if we assume that N, that is M is somewhere here, so this is what we are calling our point M, then such that the ratio of Lm is 3. So Lm, this particular ratio is 3. Then Mn is 4. So remember, Mn, this particular ratio is 4. This one is 4 here. Then we are told that find the coordinates for point M. Again, we are going to apply what we call the ratio theorem. So I'm going to consider the line that is L. Then of course we have M. Then the other one is N. Then I'm given the ratio. This ratio is 3. Then this one is 4. Then of course we have the coordinate for point L. Coordinate of L is 3, 18. Then we also have the coordinate for N, which is N has the coordinate of 10, 4. So this is 10, 4. So they want us to find the coordinate for point M. So applying the ratio theorem, if I take the coordinate for point M, it should be equal to, so I'll take the ratio 3 divided by the total ratio, which is 3 plus 4, which is 7. Then I multiply with the opposite coordinate, which is the coordinate for point N, which can be indicated as ON. Then it should be added to 4 divided by the total ratio, which is 7, which should be multiplied with the opposite coordinate, which is simply OL. So this should be equal to 3 over 7, then into bracket. The coordinate for N is actually 10, 4. So this is 10, positive 4. Then we are going to add 4 over 7 into the coordinate for OL is actually 318. So this is 318. Then of course we are going to open those brackets. Let me create some working space here. So if I open the brackets, this is what I'm going to get. Let me separate the working space here. So if I open the bracket, I'm going to get the following. So this will be OM will actually be given by, so if I open the bracket, I'm going to have into bracket, so this will be 3 over 7, then multiplied by 10, then 3 over 7 multiplied by 4. then I close the bracket. So this should be added to, if I open the other bracket, I'm going to have the following: 4 over 7, then multiplied by 3, then 4 over 7 multiplied by 18. Then I close the bracket. So this should give me, this will be 30 over 7, 30 over 7, 3 by 4, I'll get 12. So this is 12 over 7. Then of course into brackets, so I'm going to add the following. So plus 4 by 3, I'm going to get 12 over 7. Then 4 multiplied by 18, I'm going to get 72. So this is 72 divided by 7. So if I add, I'm going to get the following. So this will be, so I'll simply take the first value that I'm having here. So I want to add these values, so it will be 30 over 7. Then of course should be added to 12 over 7. Then of course 12 over 7 should be added to 72 over 7. 72 over 7. So this should give me the following. So this is what I'm going to get. So I'm going to have the following. So OM, the vector OM will actually be equal to, so if I take 30 over 7, then I add 12 over 7. If I add to 12 over 7, I'm going to get the answer as positive 6. So this one will be positive 6. Then if I take 12, that is 12 over 7, then of course I add 72 divided by 7. I'm going to get my answer as positive 12. So this one is 12. So they wanted me to find the coordinate of M. So it simply means that M, remember when you are told a coordinate, it should be stated in horizontal form. So this one will be 6, 12. So those are the coordinate for point M. So I can indicate it here. So this is 6, 12. So these are our coordinates for point M. Then, so that is part B of the question. Then in part C, we are told that if that is, if OM is produced to T such that OM to the ratio of MT is 6:1. So we are having that OM is produced to T. So which means to produce is simply to connect using a line. So such that we are told that OM and T are actually connected. So this is our M is here. Then of course, so we are given some ratio here. Let's interpret this particular ratio that we are given. So this is part C of the question. We are told that if OM is produced to T, so this is my O, then of course this is M. So let me draw a line connecting this particular two. So I'm going to have the following. So we have O, which is being connected to M, then that those ones are going to meet at a certain point that we are calling point T. So this is what we call to produce. So that is the line that we have produced. So it should meet at a certain point T. So this is our point T that is has been produced from the line OM. So we are told that they are produced such that OM, the ratio of OM to the ratio of MT, this particular ratio is 6:1. So this is my OM. So this particular ratio is 1. Then MT, this other ratio is 6. So this is 6. The ratio of MT is 6. Then of course OM, the ratio is 1. So I'm told in C Roman 1 to find the position vector of T. Again, I'm simply going to apply what we call the ratio theorem. So I'm going to use the ratio theorem such that we are going to have the following. So if I apply the ratio theorem, I need to sketch the line that we are using. So I'm going to consider line OMT. So if I consider the line OMT, so this is O. Of course, O has the coordinate of 0, 0. Then of course we have M here. We have already found the coordinate of M, which was 6, 12. then we have t outside here whose coordinates are not known. Then we are given the ratio of OM to be 1, then MT, its ratio is that is the ratio of MT. So MT, its ratio is 1, OM is actually 6. OM, this ratio is 6. So OM, the ratio is 6. So this one should be 6 here. This one should be 6. Then the other ratio here is actually 1. That the ratio of OM to MT is 6 to 1. So OM is 6, then of course MT is 1. So if I apply the ratio theorem, if I take the coordinates of M, which can be written as OM, should be able to give me 6 divided by the total ratio. Then this one should be multiplied with the opposite coordinate, which are the coordinate for T, which can be written as OT. Then we are going to add 1 divided by the total ratio is 7, which should be multiplied with the opposite coordinate, which of course is the 0, 0. So this will be given by the coordinate of M is 6, 12. So this is 6, 12. It should be equal to 6 over 7. Then OT, of course, we don't have the coordinate for T. Then plus 1 over 7. Of course, 0, 0 is the origin, which is the point 0, 0. So this will be 6, 12. 6, 12 should be able to give us 6 over 7 OT, then of course plus 7 by 0, you are simply going to get 0, 0. So this should give us the following. So of course, if I take this to the other side, I'll just remain with the 6, 12. So we have 6, 12, 6, 12 being equal to 6 over 7 OT. So if I want to get the value of T, I'll multiply both sides by the reciprocal of 6 over 7, which is 7 over 6. I also multiply this side by 7 over 6. So I'm going to have 7 over 6 into 6, 12 into 6, 12 should be equal to the vector OT, because 6 and 6 will cancel out, also 7 and 7 will cancel out. So this one means that the vector OT will be equal to into brackets 7 over 6 multiplied by 6, then 7 over 6 multiplied by 12. So this will give us OT being equal to, the 6 and 6 will cancel out, so I'll remain with 7. So this will be 7, then 6 here 1, 6 here 2, 2 by 7, I'm going to get 14. So it means that the coordinates, that is the position vector of T, so the position of vector of T will actually be 7, 14. So that is the position vector of T, which is simply OT. So the position vector, therefore position vector of T, which is simply OT, will be given by, this will be given by 7, 14. Remember, if the question was state the coordinate for point T, the coordinates will be 7, 14. So the coordinates must be stated in a horizontal manner. So the coordinate for point T is 7, 14. So these are the coordinates for point T. Then Roman 2. So in C Roman 2 of the question, they want us to show that the points L, T, B are collinear. So we have the points, we have L, then in between we have T, then of course B. They want us to show that those points are collinear. So remember, we said that collinear simply means that to show that the points lie on a straight line. And how to show that? You need to show that the any two vectors formed from the 3 points are parallel to each other, meaning that they must have a scalar multiple between them. Then you also show us that there is a point which is being shared. So we need to find the vector LT, then we also need to find the vector of TB, so that we check whether there is a scalar multiple in between them. So the vector for LT will be given by, you simply take the coordinates of T, then you subtract the coordinate of L. So this will be the coordinate of T, we already have it as 7, 14. So this is 7, 14. Then we are going to subtract the coordinate for L, which was actually 3, 18. So we subtract 3, 18, so that we are going to get 7 minus 3. 7 minus 3, we are going to get positive 4. So this is 4. Then of course 14 minus 18, 14 minus 18, you are going to get negative 4. So that means LT is actually 4, negative 4. So this will be 4, negative 4. Then you also need to find TB. So the vector TB should give us, we'll take the coordinate of that is the coordinates for, that is, we are going to take the coordinate for T, then of course we subtract the that is the coordinate of B minus those of T. So this one should give us the coordinate of B, then you are going to subtract the coordinate of T. So this will give us the coordinate of B. Point B was I believe we have point B, which was 15, 6. So this is 15, 6. Then we are going to subtract the coordinate for T. Coordinate for T was 7, 14. So this is 7, 14. So this is 7, 14, which is going to give us the following. So if I take 15 minus 7, 15 minus 7, I'm going to get positive 8. So this is 8. Then of course 6 minus 14, I'm going to get negative 8. So this is my negative 8. So this is negative 8. Then I'm going to separate this particular 2. So let me draw a line here to separate them. So it simply means that if so this is what we are going to do. We'll take LT. If you take LT, it should give us a constant multiplied by TB for them to be collinear, that there must be a scalar multiple between these two. Therefore our LT, we have found it as 4, negative 4. Then this one should be able to give us a constant K, then into bracket TB. So TB, we got it as 8, negative 8. Therefore it means that if I open the bracket, it means that 4, negative 4 should actually give us this is 8K, then of course minus 8K. So if I compute for the value of K, it simply means that 4 is equals to 8K. Then if I divide through that is by 8, I also divide through by 8, it simply means that the value of K will actually be equal to a half. So my K will be a half. Remember, you can also work with the other coordinates. The answers should be the same. So suppose somebody worked with the lower coordinates, you will have negative 4 being equal to negative 8K. So if you divide through by negative 8, or you also divide through by negative 8, then you will find the value of K still being equal to a half. Therefore it means that LT, this equation here, LT is actually equal to KTB, but we have the value of K, which is actually a half, then multiplied by TB. So you can express it this way, or you can multiply through by 2, so that you have 2LT being equal to TB. So this one shows that the vector LT and TB are actually parallel to each other, since there is a scalar multiple in between them. And you also tell us that the point and the point T is common, or is being shared. It is point T is common. So once you're able to show that one vector is a scalar multiple of the other and there is a shared point, then you have proved that the 3 points L, T, and B are collinear. We'll therefore say hence, L, T, and B, L, T, and B are collinear. L, T, and B are collinear. They are collinear. So in our next class, we'll be looking at further examples on vectors. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time,